There was a single moment that changed everything. It's the reason that you're here today, and the reason that the cells that make up your body have something powerful lurking within. Our home planet, Earth, formed somewhere in the region of 4.6 billion years ago. It was a scorching ball of rock covered in oceans of lava and bombarded by meteors, so not really somewhere that you'd expect life to be able to sprout. But life didn't hang around. 1 billion years after the planet formed and just 500 million years after conditions became a little less violent, it appeared. So really, in the grand scale of things, as soon as it was possible, life began. Some of the earliest life forms were a group of simple, single-celled microorganisms that we call prokaryotes. This group is split into two smaller groups, or domains, bacteria and archaea. And for almost 2 billion years, it pretty much stayed just like this: simple, single-celled, microscopic organisms. If you were to look at an ocean back then, or a river, or anything really without a microscope, you might think that it was completely barren, a completely lifeless abyss. That is until it all changed. Even though these organisms were simple compared to even some of the most simple organisms today, they were complex enough to not just be sitting around doing nothing at all. And at some point, possibly in a chance encounter, a smaller bacterium found its way inside a larger cell, which is thought to have been a kind of modified archaean. But what's incredible is that instead of being digested by the bigger host cell, and instead of actually killing the host cell, the smaller bacterium survived. Okay, so now we've got a smaller bacterium inside of a larger cell, and you might be thinking, what's the big deal, Tom? Well, the smaller cell was actually capable of doing something that made this chance interaction especially incredible. It could use oxygen to produce energy in what is known as aerobic metabolism, whilst the larger cell probably couldn't and would have used anaerobic metabolism. And what's vital to understand here is that aerobic metabolism is vastly more efficient and can produce massive amounts more energy than anaerobic metabolism can. So, whilst the larger cell could provide protection and nutrients, the smaller bacteria could actually better use the nutrients and leverage oxygen to produce more energy. And ultimately, because of these benefits that they could provide to each other, a relationship formed between the two, known as an endosymbiotic relationship. And what's important is that it meant that the larger host cell suddenly had access to a massive amount of energy. And it's this part of the equation that's, well, powerful. You see, prokaryotic organisms are limited in their size and complexity that they can become. To increase complexity, a cell must increase the amount of DNA that it contains, and the amount of proteins, which are vitally important building blocks of life, that it creates from that DNA. But using DNA to create proteins is extremely energy demanding, and can actually make up the majority of a cell's energy usage. The problem here is that prokaryotes rely solely on methods of gaining nutrients that just wouldn't be able to keep up with the increased energy demands after a certain point, which means that their development into increased complexity is literally limited by energy. So this influx of energy that came from this smaller cell inside this larger cell meant that there was available energy to be used elsewhere by the larger cell, and it opened the door to a whole new level of complexity. This single random event between two prokaryotes led to the birth of the more complex cell type known as the eukaryotes, a domain of organisms that includes all animals, plants, and fungi today. Over time, as the cells within cells multiplied and were passed on through cell division to future generations, the relationship between the organisms became so close that they each became unable to survive without the other. The smaller cells lost heaps of their DNA and even transferred some of it to their larger host cells, until over time they became what we now call mitochondria. And the energy provided by these little guys is huge. They actually have the ability to produce a field strength of 30 million volts per meter, which, in other words, is the equivalent of a bolt of lightning. For almost 2 billion years, life stayed simple, and within just 500 million years after this single event, the ancestors of modern plants, fungi, and animals split into separate lineages. Multicellular life appeared, sponges evolved, vertebrates, plants, fungi, fish, insects, amphibians, reptiles, mammals. All the life that you are used to seeing without the use of a microscope, they all came from this single chance encounter. They're all here thanks to the energy provided by those tiny cells that became mitochondria. And yep, it led to us. It led to me, it led to you, and to everyone you've ever known or ever will know. We're all here thanks to that single chance event. And we're still powered by the remnants of those ancient life forms today. Hey guys, thank you so much for checking out this video. Really hope you enjoyed it. But before you go, I've got to say a massive thank you to Julia Van Etten, who's a PhD student that posts beautiful images and videos through the lens of a microscope over on Instagram. And she was kind enough to let me use some of them in this very video. So if that sounds like something you might be interested in checking out, which I highly recommend you do, go and find her on Instagram at couch_microscopy. So that wraps up this episode. Until next time, I'm Tom. You keep discovering the world around you, and I'll see you then.